in the last video, I derived the distance formula for you. And right now we're just going to do some applications of the distance formula before we begin to learn the midpoint formula. So the distance formula again says the distance between 2 points with coordinates x1, y1 and x2, y2 are d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, just as we did with slope, does it matter which point you start with? No, it's not going to matter because the difference is squared. So whichever point you designate as x1, y1 or x2, y2 does not matter. It will still work. Let's do a problem if we're talking about specifics. And I'll just put this in a different color because my marker's dying. So let's say x1, y1 is the point -1, 3, and x2, y2 is the point 5, 2. Okay? Well, all I'm going to do is I'm going to use my distance formula. D equals, and I've already written it, so there's no need to rewrite it. I'm going to plug in x2 minus x1. Well, my x2 is 5 minus my x1, which is -1, and square it, plus y2. Well, my y2 is 2 minus y1, which is 3 squared. You see, whether this was 3 minus 2 or 2 minus 3, the number I get is squared, you'll get the same number. D equals 5 plus 1 is 6, squared is 36, plus -1 squared plus 1. And I end up with the square root of 37. And so the distance between the points -1, 3 and 5, 2 are the square root of 37. You can leave it like this unless it's a problem that's asking you for something specific, like what is the length of a toaster or a piano or whatever it would be. And then you have to actually give them a value in inches or feet or whatever. But for the purposes of just simple triangles, we're just going to use, or simple, just two general coordinate points, we're going to leave it as square root of 37 because that's actually much more exact than when you go down to the tenths or the hundredths. Okay, so that's just an introduction to this. We just did example 1. And I want to start example 2, but I don't have quite enough room, so I'm going to change papers here and start fresh. In example 2, is saying find a missing coordinate. And essentially it's using the distance formula, but in a different way. So here you're told you're given the distance. So you're saying the distance, which previously you had to find, but here you're being given it, the distance between (3, -5) and 7, and this is the missing coordinate, B, where you're not being told what that is 5 units. And the question is, find the value of b. Well, again, this is just using the formula. And we're going to set it up. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. I strongly recommend having you write this down each time so you don't make a mistake. All right, well, in this situation, we know what distance is, and that's 5. So we're going to put that right in. We know what both x's are. x2, we'll call this x2, is 7. x1 is 3. And we're squaring that. We don't know what y2 is, so we're just going to put a b in here because that's what we're solving for. But we do know what y1 is, so minus -5, and again, it's squared. So let's see what happens. 5 equals the square root of, well, 7 minus 3 is 4, 4 squared is 16, plus you get b plus 5 squared. Well, clearly we're going to get something quadratic in there. And so we're going to end up over here with square root of 16 plus. This, as I showed you previously, is a perfect square binomial. If you'll remember, this is b plus 5 times b plus 5, right? So you can't do not do b squared plus 5 squared. Those are, that's a partial solution. Because if you do just that, you're going to miss the 5 times b and 5 times b that need to be added together. So if you don't know right away how to do this, I strongly suggest you work it out on the side. And I am going to just do this over here because I know some of you are still getting this wrong. And I want to make sure you remember how to do it right. This means b plus 5, b plus 5, which means b squared plus 5b plus 5b plus 25. And so when I combine that, I get b squared plus 10b plus 25. All right. Well, now that I know what b plus 5 squared is, I'm going to put that back in here, and I'm going to put in b squared plus 10b plus 25. Now, obviously, if it's a quadratic, I have to combine the 16 and the 25, and it's still all equal to 5 in the front. So 5 equals the square root of b squared plus 10b, but combining the two constants, 16 and 25, I'm going to end up with 41. So if you remember from the last chapter, what do we do when we have a square root on one side that we want to get rid of? Well, the opposite operation is squaring, right? So I'm going to square this, and whatever I do to one side, I have to do to the other. Conveniently, that's going to get rid of that square root, and I'm going to end up with 25 equals b squared plus 10b plus 41. Now I'm close finally to being able to solve this quadratic for b, but I have to move 25 over to this side. When I subtract it from both sides, I get b squared plus 10b, and 41 minus 25 is going to give me 16. Well, I'm almost done, and if those of you who have eagle eyes and know your multiplication tables very well are probably seeing exactly what the factors are here. And you can see that 8 times 2 is 16, and 8 plus 2 is 10. So here we go. And if I solve, my value of b is either -2 or -8. And what that means is that there are two ways that that distance can be solved. That there's both a negative and a positive solution that will work to find that missing coordinate. Okay. I'm going to have you do guided practice number 4, which relates to this. So I'm going to suggest you pause that video while I'm going to start it for you and solve it just so you get some practice with it. And then we're going to move on to the midpoint formula. Okay, there we go. Guided practice 4. The distance between point 1A and 4,2, and the distance we're being told equals 3 units. Okay. So find the value of A. All right, well, we're going to do what we did in example 2. We're going to see 3 equals the square root of x2 minus x1 is 4 minus 1 squared plus y2 minus y12 minus a squared. When I work that out, 4 minus 1 is 3, 3 squared is 9, plus 2 squared is 4. 2 times negative a is negative 2a, and I have 2 of those, so minus 4a, and negative a squared is plus a squared. When I combine everything in that square root, I get 3 equals the square root. I'm going to move things to proper order in descending degree, a squared minus 4a plus 13. I'm going to square both sides as I did before. So that I can get rid of my square root. And when I do that, I get 9 equals a squared minus 4a plus 13. And I subtract 9 from both sides and get 0 equals a squared minus 4a plus 4. And that's looking suspiciously like a perfect square trinomial. Let's see. If I factor, because I know negative 2 times negative 2 will give me a positive 4. And if I add them up, I get a negative 4a. So I could write it this way, or I could also write a minus 2 squared. It doesn't matter. Either way, I have one single answer for this, and that's a equals 2. So that is the answer to guided practice number 4. I am going to stop this and then move on to the midpoint formula.